Good day, sir. Try number 4. I'm not gonna lie, it's quite hard to do this in 10 minutes. So, this is my game. I created an old school Legend of Zelda type of game with like a map you can explore and some collectibles to pick up and some a house and a cave you can enter. I downloaded most of my sprites from this Hyperluminal 2D Fantasy Forest tile set where I use the forest, the roads, the grass, and I use this to create the game world. Now I have 6 different scenes, and we can start with the menu scene where we press play. I just have like this, like a start screen with play and exit. You press the play button, you enter the scene. Every time, hold up, I have to pick up on our canvas key count. There we go. So now in the game scene, if I press A, if I walk around, I change the animation to walking. If I stand still, it changes back to idle. And then here you can walk around and pick stuff up. You saw it started on gems times 0, and when I picked up 1 gem, it changed to gems times 1. I can do the same for the keys. Now it's on keys times 1. I can walk around, just explore the map a bit. And here's a house, and see, now it's on gems times 2. So I have a script for counting that. And when you walk into the house, it loads a different scene, the house scene, where you can walk around the house and see what's up. And if you leave the house, you're back into the world. Now let me go through the scripts I've made. So the first one is the animation one. I pretty much just learned this from, I think it was week 9 or 10, where we did animations inside the tutorials, where I created an animation state, and in the animation state I created 2 different integers, 0 and 1, 0 being idle and 1 being running. And I set it so that when you press the W key, it changes the animation state from 0 to 1, so that's my condition. And when you let go of the W key, it changes it back to 0. So that's the changing between running and idle. And I did this for all my keys, because since I'm going up, down, left, and right, it's going to run every direction you go. And when you press nothing, it goes back to 0. Next, I have the button press. This is literally the code I have for pressing the button in my menu screen, where if you press the button, it opens the game scene. Then I have the camera clamp. Yeah, this one is the one I had a bit of trouble with. I didn't want my player character to leave the boundaries of my game, and I didn't know how to like keep him within. And I saw this some code about math at clamp, but I didn't like understand it. And then I came across this, where it transforms the position of the character within the boundaries. So if he starts outside of the boundaries, it will transform him to within the boundaries, and the boundaries are set for x minus 10 and 21 and y 5 and 26 pretty much. Like when I was first fiddling around with this, and my the y position of my character was outside of these boundaries, it would teleport the player within the boundaries, and it will not let the player leave these boundaries. So it works pretty much as a clamp, but I understand it this way, so that's why I chose this method. And then this is the clamp for the game world, and this is the clamp for the cave. I also have a cave, what's called, where one can walk into. Okay, I can show it quickly. So you press play, look around, and then every time this key, I need to save it. And then another gem here, sneaky gem. Then you walk into the cave, and then here's the cave, and then you cannot leave the boundaries of the cave. Like in my actual game scene, I added trees around the edges with box sliders, which in essence would do the same, but this one actually does not have any box sliders on the edges, but it doesn't allow me to leave the cave. Then when I walk through the door, I'm back in the world. Let's go back to the scripts. So now I have a few scene managers, where in the cave scene, here it is, I made a tag called entrance 2, and I attached this tag to the door sprite so that when the player collides with the tag of entrance 2, which is the door sprite, it would load the game cave. And I have the same for cave to game, game to cave. If it runs into the cave sprite, it runs to the, what's it called, where it is. If it runs into this cave, which I tagged cave, then if it runs into if it collides with this sprite, then it loads the scene cave. So that's how I did all my like scene manager. So this one's house. It runs If it collides with the house, it opens the house. So let's see. So that's game to game, and then game to house is going from the game to the house. It's just the same scene manager load scene script. And then you have house to game, which is goes from the house to the game. And then here I need to explain one thing. When you leave the cave and into the game world, what I wanted to do is I wanted to teleport the character to outside of the cave. Because every time I had only one game scene and I exited the house, I would teleport right here. And I didn't want that. I want the character to teleport outside the house. And the same for the cave. When he left the cave into the game world, it teleported back to like the beginning, which I didn't want because I would break immersion. So I tried to look for a way to teleport my character on the condition that when when the scene game is loaded from house, that he gets teleported. But I couldn't find a way to do it. So what I did, I read this cheap method. What you can do is you can duplicate your game scene. So I have the game house, the game cave, and the game house. When I load the game house, he spawns here, and when I load the game cave, he spawns here. So when you leave the cave, you load the game cave scene, and when you leave the house, you load the game house scene. So in essence, it works. But if what's it called, your game becomes quite expansive and you have like a million scenes, then this method does not work at all. But for this level, for my first time, it works. It's a viable method, I think. And next is the player move. Oh yeah, wait, before we do that, I have one more, the exit game. So this is literally the script for what's called, if you press the exit button in the menu screen, it quits the application. And because Unity doesn't actually close, I added a debug.log here to check in the console if it's working, and it works. And now the player move. So in here, I did two different scripts actually. I have my player movement script and I have my collectible script. So for my player movement script, we need float speed 10F and rigid body 2D. And my rigid body 2D, I defined here as get component rigid body, so it acts as the component. And then I tried to use the method we used in one of the first weeks for the transformation, but this only works along the x-axis or one of the axes. And when I tried to implement my own version of it for the y-axis as well, my character was just moving diagonally up and diagonally down. And then I tried to look for a different method, and I came across this method where you get input get axis horizontal, and horizontal and vertical are already defined within Unity, so I didn't need to define them. So I create a new variable h-axis, which is equal to that, and y-axis, which is equal to that, and then a new vector3 move, which is a new vector3 h-axis, y-axis, times the speed times the delta time. And the speed is up here, 10F, which I change in the inspector in Unity, and times the delta time, which makes it the speed per second. And then I transformed my rigid body 2D position based on this new vector. So that's my movement script. And secondly, I have the collectible script. So I created a text called context gem, a text called context key, and an integer called count gem and count key. And here I created count gem equal to 0, count key equal to 0. The count text gem, which is the text, is equal to the string of gems times plus the count gem value. And it attaches it to the string. So this is both for gems and keys. And here, what I did was that if the player like collides with the tag, it triggers a value. So what it does, it triggers the set active, and it triggers like the game object to set active. And the set active thing is literally if you click here, oh sorry, the pickup, and then you go to the gem. What it does is the set active false unclicks this button, which makes the gem disappear. And then what's it called? I set the context gem to equals to the gems times the context gem equal to the gems times the string plus the count gem, and the count gem is equal to count gem equals count gem plus 1. So every time you pick up a gem, it adds a value of 1. So that's where you get the times 1, times 2, times 3, times 4, times 5. And I did this also for the keys. It's the same code. That's quite nice. I like that. I like doing that. And finally, we have the sprite flip. Now, what this does is that when I walk to the left in my game, my player the sprite did actually not flip along the x-axis. I just like moonwalk backwards. So I looked for a solution, and all one really has to do is press this flip in the sprite renderer, press this X flip. But you can't do that while you're playing the game. So I found a script which does this. And I made it so that if you press the key code A, it flips the sprite along the flip X to true. And when you press D, the flip X equals to false. So when you press A, it clicks the button. And when you press D, it unclicks the button. So that's when you walk to the right, you're not flipped. When you're walking to the left, it's flipped. And that is pretty much like explanation of the code of my game. And I hope you enjoy it. Thank you very much for listening. Have a good day, sir.